and he wouldn't die as quickly. He lasted a year. And the woman that he had intended to marry mourned for 40 years. She never got over it. Justin, where's the vertex? On that happy note. Okay, well, tell us what you got, and then we'll talk about it. You got 3 what? -5. Okay, tell us how you got those numbers.
X minus 3 squared, kind of like top of the square, and how many ones you put in on. Then I put the -9 on the outside.
Okay. So sounds to me like what you did is you completed the square for something that the square is already completed. So if I gave you y equals x squared minus 6x plus 4, you would have to add 9 to make this a square and subtract 9 to balance it out. That's a reasonable thought process, except here's the problem. I didn't give you that. I gave you the completed square already. So what you're doing is you're doing a step that's already been done for you. And when you do the step that's already been done, what that does is it actually then messes it up. So let's assume, Justin, that the square has already been completed for you, and that you don't have to put in the -9 to balance it out, because that's already been done. Where do you think the y value is of the vertex now? +4. There it is. There it is. Good. Guys, I love the thought process. I love the fact that he was able to walk me through the steps of what he did and what he thought so that we were able to figure out the flaw in the logic. Instead of 3, 4 or 3, -5. How'd you get that? Oh, I don't know. Just seemed right. Well, then we don't know what to fix. So that was awesome. Thank you, Justin. 3, 4. There's 3. There's 4. There's the vertex. Let's do the quick graph. Our survey says, Xander, where are the next set of points?
I said 0.
Oh, make it easier than that. How much to where? Just how much do I move? Don't tell me the coordinates of the points. How much do I move for a quick graph from here?
Up 1 over 1.
Up 1 over 1. Because this is so much easier than thinking to yourself, where are the different points on the graph? It's just up 1 over 1. Where's the next set of points, Xander?
It's like up 1 over. It's just like up 4.
It's up 4, but it's over how much? Remember, we're starting at the vertex. I've already gone over 1. What's next?
2.
Over 2. Yeah. So I go over 2 and up 4. That takes me to 6, 7, 8. I didn't really make my graph tall enough. Didn't plan ahead. And symmetry says I'm right there. And there is a quick graph. Boom. That's the graph y equals x minus 3 squared plus 4. That's so easy, isn't it? So much better than type it into your calculator and then look at the table and then start putting dots on it. Oh my gosh, that is as easy as it gets. I like it. All right. Amber, where's the vertex of this one? -1 comma -3. So -1, -3. This one is down here. Cool. Thank you, Amber. Quick graph. Here we go. Dominic just arrived. I won't put him on the spot quite yet.
I'll do it.
Oh, you want to do it?
Sure.
Good. Where's my next set of points?
Your next set of points will be. They'd be your x-intercepts, and they would be.
No. I'm at the vertex. I just want to do my quick graph points. Where do I go? Okay.
Next set would be your x-intercepts.
Let What's
there one before it?
Daniel?
What?
Just because he's had more time to think about it. Daniel.
You go up one.
Okay, over 1. Guys, I recommend that you always start by thinking about over and then up instead of up and then over. I know on slope we go rise over run, but if you think about I'm going out 1 and then think about how much you have to go up, because the up is the only part that's going to change. What did you forget, Daniel?
I forgot about the 2.
So over 1 up?
2.
2 instead of 1. Because we've got a stretch factor.
But then you can't mark your x-intercept.
Don't care. You're right. I don't care. Daniel, where's the next set of points? And I'll tell you why I don't care in just a second.
Over 2 up 8.
Aha! Over 2 up 8 instead of 4. Boom. Over 2 up 3, 4, 5, 6, 7, 8. And then symmetry says right there. Now, let's get back to Dominic's point about my x-intercepts. What do you notice about the x-intercepts on this graph?
They're a pain in the ass to mark.
Yes, although we won't say pain in the ass in my class,
Okay.
because it's just a little more crude than we really need to say. But we could say they're a pain. Why are they a pain, Dominic?
Because they're in between 2 points.
They're not whole numbers. They're decimals. But you know what? The question was not, where are the x-intercepts? We don't care. The question was, can you draw a graph of this quadratic? And boom, we drew a graph of the quadratic. Where are the x-intercepts? Approximately negative 2 point something and approximately 0 point something. Don't care, because that's not the question. Hey, that does bring up an interesting point, though. What if I wanted to know what the x-intercepts were? What's y equal to at the x-intercepts?
0.
So could I write 0 equals 2 times x plus 1 squared minus 3 and then just solve that for x? Would it? How do I get rid of a minus 3? Add 3 to both sides. How do I get rid of a multiplied by 2? How do I get rid of a squared? Square root. How do I get rid of a plus 1? Oh, look at that. There's my x-intercepts. And I could get out my calculator and I could type these in and find out, whoops, sorry, my bad. I could type this into my calculator and get the decimal if I wanted. Guys, this is a heck of a lot easier than squaring the x plus 1 squared and then writing the whole thing out. And by the way, it doesn't factor because they're not whole numbers. So then I'd have to use the quadratic formula. And guess what I would get when I use the quadratic formula? Boom! All right, but that's not what we're talking about today. Today we're talking about transformations. Let's talk about another function instead of a squared. Today's objective is to learn, now that you know everything there is to know about quadratics, right? Fair to put on your resume that you were all quadratic masters? No, nod your head yes, Eliana. Don't nod your head no. Nod your head yes. Absolutely. If I said, put down something you're awesome at in my math class, one of the things you should be able to put down right now is quadratics. You know everything there is to know. You know how to write them in vertex form. You know how to find the x-intercepts. You know how to find the y-intercepts. You know how to make quick graphs. There isn't anything else to learn about quadratics. So we're going to move on today to cubics. And the first thing that I'm going to ask you to do, you're going to be able to use your Chromebooks or your graphing calculators. Desmos Grapher is a good one for this. First thing I'm going to ask you to do is a full investigation. So let's remind ourselves what that means. Can somebody tell me one thing that is included in a full investigation? What's one thing that you can find out about any equation? Anybody? What? If it has a vertex, yes, you can find the vertex, but I'm going to generalize that and I'm going to say, are there any important points? Quadratics have a vertex. So for example, a vertex. Not all equations have a vertex. What else? Anybody? Come on, somebody over here. Getting lots of feedback from the back corner there. The two people in the back corner. Anybody else? Luis, one thing you could figure out about an equation. Say again?
I'm not sure, but
well, I mean, that's the equation, x to the third power. But what's one thing that if I said, go find something out about that equation, what could you figure out? What would you do? You type it into your calculator, then what?
I'm not sure.
No idea. You'd type in y equals x cubed into your calculator, and then you would sit there saying, oh, Mr. Armering, I don't know what to do next. Yes, okay, and then what? What can you make with your calculator?
You can also graph.
Okay. Good. We're going to make a graph. By the way, we're going to make a quick graph. Eliana, what's something else? What points? X-intercepts. Ooh, and y-intercepts. Good. X and y-intercepts. Excellent. Daniel, something else. Do I have to drag it out of you guys? Come on, give me something here. Work with me. Okay, so slope is actually something that sort of goes along with linear functions, because think about a quadratic. The steepness is changing all the time. So we don't say what's the slope of the quadratic, just because it depends where you are. It gets steeper and steeper. What else? Something else you could find in your calculator or figure out about an equation. Think about all those buttons in your calculator. What could you get it to tell you? Nothing? Xander?
Very like the graph.
You mean like a graph like that? How about a different one?
Like the line of the equation.
But that's the graph, isn't it?
Yeah.
What else?
I don't know.
Amber? Tucker?
Intercept.
Yeah, absolutely. Oh, you guys heard the quote, "You're killing me, Smalls"? Dominic? Justin? How about a table? Oh yeah. Oh, that kind of thing. Oh, I didn't know you meant like that, Mr. Armerding. How about the domain? How about the range? Oh, I didn't know you meant stuff like that, Mr. Harding. How about, does this function have any asymptotes? How about a description of the function using mathematical language? Things like increasing or decreasing and concave up or down. Remember, concave means when you've got a curve, which side is the cave? Is it below the curve or is it above the curve? That's the cave. Okay? Guys, when you make your table, aren't you thinking about points that would make it easy to quick graph, which means no decimals? Full investigation, 6 minutes, go. There's the equation. You should have your Chromebook or your calculator out in front of you. You should be giving a full investigation of that function. do. That should reach. Hopefully. Yes. Cool. You betcha. About one more minute. Have as much stuff as you can from that list of things on the board. I'm gonna start asking people to give me some feedback. What numbers you can put on your table?
Probably 1, 1.
Cool, yeah, definitely good. You know that you can create a table over here by, oh, you gotta hit y equals x cubed, and then it will allow you to create a table instead of just x cubed. It'll give you a graph, but now, I think you need to click on the settings box, maybe? Yeah, now you can click on that, and it'll give you a table. Cool, huh? You need to go that far for a quick graph? Which ones would you put? You don't have to erase any, but. Yeah, I agree. Yeah, so let's get some of the rest of that stuff down. You got a table. Zoom standard. Press zoom, and then choose option number 6. You betcha. There they are. Also, I don't know if you knew this, but if you type X, go ahead and type X cubed. Power is right there. Uh-oh, that's squared. Okay, so now, hit enter. Oh yeah, it's already good there. First little settings thing. That little table. Boom, makes you a table.
You started.
Yeah. You know, if you tap little settings, gear, now you can make a table. Yeah. Why do you have y equals negative x on your graph? Oh, I see what you're saying, I see what you're saying. So, good thought, except that the word vertex actually means highest or lowest point. So, this one doesn't have a vertex, because vertex, like on gravel, the vertex is that lowest point, and your gravel looks like that, and it's the highest point, it looks like that. If you had a diamond, that's a vertex. But this isn't actually a vertex, it's an important point, because we see some changeover. But we don't, but it's not an actual vertex.
I always thought the vertex is like here.
Oh, I see what you're saying, looking for lines of symmetry. Yeah, that's a little bit different. Good thoughts, but just not the word. Cool. Why? But why?
Why what?
What are you going for there? Just playing? However, in all the playing, I don't see domain and range. Oh, interesting. So what possible x values on this graph? What possible y values on this graph? Well, now those are the intercepts, right? Well, those aren't even the intercepts, those are part of the table. Well, no, I agree with you that they're points on the graph, but they aren't intercepts, because intercepts are where it crosses an axis, right? All right, guys, let's see what we got. We'll start with Luis, your choice. Give us one.
Okay.
Go.
So it will be -2 and -1. I mean -8 and -1 and -1. 0, 0, 1, 1, and 2, 8.
Guys, I love that for a quick graph table. 5 points, just like we do with the quadratic, and they're all easy points. So let's go 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4. We got 0, 0, 1, 1, 2, 8. Whoops. We got -1, -1, -2, -8. And hey, wow, look at that beautiful graph. I like including the 2 8s because if I were to just draw a graph, that looked like this, what would you probably be inclined to say? What does that look like? Linear. Yeah. If I just drew these points right here, in fact, there is a line that goes right through those points. But as soon as I do that and this, it's pretty darn obvious that, in fact, no, this is not that line. So yeah, good. Thanks, Luis. I like it. All right, next. Tucker, pick one.
X-intercept.
Go.
0, 0,
And since you're doing the x-intercept, why don't you do the y-intercept?
0, 0.
Oh, wow. Crazy coincidence. Cool. Eliana, pick one.
I had one up there.
Okay. Any important points?
I don't know.
See anything? See any point where you notice something happening that you're like, wow, that seems sort of important? Nothing remotely interesting about that graph. It's just like, it's blue stuff on a board.
I don't know.
Looking at the shape, you see anything about the shape that you're like, hey, look, there's something interesting about that shape.
I don't know how to describe it.
Try.
It's like, I don't know.
Okay, no more I don't knows. You've said that like 18 times. You've used up your allotment of I don't knows. Come on, give us something. Okay, definitely. Hey, let's talk about description then. This is increasing. How about concavity, Eliana? What do you notice about the concavity? Which direction is it concave? Is it concave up? Is it concave down? Does it change?
Changes.
Where does it change?
Like, I don't know.
Is there a point on the graph where it changes from being concave down to concave up?
0, 0.
Boom. Yeah. Concave down on the left, concave up on the right. And it changes concavity at 0, 0. Guys, we actually have a name for that point. This is called an inflection point. This is a word you have not heard before, at least in this context. Inflection is where something changes concavity. It changes from either concave down to concave up, or from concave up to concave down. Awesome, Eliana, thank you for sticking with that. You guys notice how I drag answers out of you kicking and screaming, even when you really don't want to? It's okay. I'm good with it. I love it. Eduardo's not here today. Jared's not here today. So we all go back into Xander. Give us one.
Like the concave.
Wait, what? No. Give us one we haven't done yet.
Uh,
Looks like to me we got domain, range, and asymptotes.
okay, so for domain, I got negative infinity, in that like one side.
Yeah, which direction is it going to point?
Towards the infinity.
So that means less than.
Yeah, less than x, and then less than infinity.
Cool. And the range?
Pretty much the same thing, but for the y, it's like y.
So say it just for practice. Go.
It's negative infinity, less than y, negative, or actually no, it's less than infinity.
I love it. Beautiful. Couldn't be better. Well done. Thank you. All right. Dominic, pick one. By the way, there's only one left. Pick that one. Are there any asymptotes on this graph? Is there a line that this function approaches but never reaches?
There's two.
A line? Not a point, but a line that this approaches but never reaches.
No.
The correct answer is no. And Xander already told us that. These go to infinity. If they didn't go to infinity, that means that there would be an asymptote. Remember, an asymptote looks like this. And so if this was x equals 2, then there'd be an asymptote at x equals 2. But something can't go to infinity and have an asymptote because there's no number that it approaches but never reaches. It just keeps getting bigger and bigger and bigger and bigger. So in fact, the correct answer is none. Good. Okay, next question. I want you to take y equals x cubed, and in your Desmos Chromebook calculator, I want you to figure out how to shift this graph up by 4. What do you need to do in your calculator or in your Desmos grapher to shift that graph up by 4? Go. Play around with it. Experiment. Try different things. And do it until you've got a graph that is 4 higher than the current quick graph.
It has to keep the cube.
Gotta keep the cube, because otherwise it's a different function. What could you do that equation to make it 4 higher? So what did that do? Did it shift it up by 4? What did it do instead? Well, don't change it. Tell me what you see. What did that equation do? Because this is part of the exploration process, is that you have discovered something. Now, it's not what we want for right now, but it might come up again later. So what did that 4 do? What do you see on your graph? Let's drag that down. If I go to x equals 1, it's 4 times as steep, isn't it? Well, file that away in your memory, because later on, when I say, okay, how do I make it steeper? You've already figured that out. Now, we also know that doesn't shift the whole thing up by 4. Try something different, but keep that in your memory, okay? Ah. Aha, I like it. Yes. Yes. All right, here we go. How do I shift it up by 4? Our survey says, Eliana.
Plus 4.
Y equals x cubed plus 4. So here's my next question. How do I shift down by 2? Go. Down by 2. This one.
Down by 2 from the original.
From the original.
Okay.
Yeah, we're done with that. We don't care about it anymore. And make sure you're writing this stuff down as we do it. The whole point of taking notes is to have a record of what you did so that when you're thinking about it later, you go back and say, oh yeah, there was the process that we went through. It can really help you remember when you're writing stuff down. Turns out there is a link between your hands and your brain. When you write stuff down, you're more likely to remember it. All right, here we go. Justin,
There's 2 at the end.
just why don't you tell me the equation instead?
Y equals 3 cubed minus
3 cubed?
no, it's called.
X cubed, right? Good. Now, what I want to know is I want you to shift up or down by k. And when you put the equation in your calculator to test it, it is going to ask you, do you want to make a slider for k? And you're going to say, yes. And then you can drag the slider back and forth and see if it does what you expect it to do. Shift up or down by some number k, some changeable number k. Go. Except instead of a number, we want to do it by how much? K. So instead of a number, put a K in there, see what happens. No, now you got 4 Ks. Get rid of the 4. Now put the K. Now, see what happens. Oh, you're in the table. Close the table and do it in the equation. Oh, put Y equals. I'm making it a little more complicated, but. Got an arrow to the right. Yeah, see you're in the power still. There you go. And now it says you want to make a slider. And now it's like, oh, where's your graph? Oh, look at your zoom. Dude, your zoom looks crazy. There you go. All right, let's see what we got. Tucker.
I put in 5.7.
I have no idea what that means.
Oh, K is, might as well just do K plus 6.
I'm still confused. What equation did you type
Oh.
into your grapher?
Y equals x cubed plus 6.
Okay, but that's not up or down by k, that's up by 6, is it not? But I want you to do up or down by some number k that we can change. So what would you put instead of a 6? K. Guys, if you type this into your Desmos, it will ask you if you want to make a slider out of k, and you say yes. And then it will let you just change k by moving the slider back and forth. You don't have to put in a specific number. You can just drag the slider back and forth, and it will make it bigger, it will make it smaller, it will make it negative. Yeah, Dominic.
Wouldn't you have to then put in a minus one too?
Good question. Do I have to then put a negative? I've got y equals x cubed plus k. Do I have to have a y equals x cubed minus k? Yes or no? Why or why not? What do you think?
Yes.
Okay, I got one vote for yes. What do you think? Here's a question. Who's got a slider in their computer right now for k? Who's got y equals x cubed plus k in there with a slider? Xander, what happens if you drag that slider to the left? What happens to the value of k, and what happens to the graph?
There goes down.
And what's the value of k when it's going down?
Like negative.
Stop right there. That's the correct answer, is it not? If I make k negative, my graph goes down. If I make k positive, my graph goes up. Do I need to have another equation that's minus k? No, because minus k is exactly the same thing as saying just add a negative. And there's no reason to have two separate equations if I can just make k negative. I've covered what Dominic was thinking about. What he was wondering about is, how do I make it go down? I type in the equation plus k, but then I make k equal to a negative number. Boom, my graph goes down. We cool with that? Does it make sense to everybody? All right. Awesome. Well, that was fun. Let's do something different. Write an equation that will take the whole cubic and move it to the left. Play around in Desmos. Put in a 4 somewhere. See if you can get that thing to move to the left. We already know how to make it go up or down. How could you just make the whole thing just move to the left? Start typing stuff into Desmos, see what happens. Make it happen. I'll give you a hint. Do I need to give you a hint, or shall I hold off on a hint? I'll let you play for a minute here, and then I'll give you a hint. Here's the hint. If you're completely stuck, flip back in your notes and look at how we did this with a quadratic. Maybe, just maybe, it'll work the same from a quadratic and a cubic. Left by 4. How did we make that quadratic go left by 4? Ooh. It's even highlighted in some people's notes. I love it. Aren't you happy I said you should highlight this? I keep going because we didn't do this till after we talked about shifting left and right. Keep going. so cool to be able to flip back through your notebook and then be like, oh my gosh, there it is.
Right here.
Walmart.
I know it's where the Walmart.
I don't know about Rite Aid. I don't know if that's the kind of thing. I mean, they've got like a little tiny section of school stuff, but it's usually pencils and pens. I have some notebooks, but not much. But yeah, Walmart always has a huge section of notebooks. I think usually they even carry the graphic for ones too. Either that or Office Max down by Sunset. All right, left by 4. Let's see what we got. Let's see who's got it. Daniel, what you got?
I did X,
Start with y equals, say it.
Y equals X minus 8.
Oh, but I want to do left by 4. What do I have to put in there instead of h?
That would be 4.
X minus 4? Is that going to make it move to the left? Everybody type in x minus 4 cubed and tell me which direction it moves. Parentheses x minus 4 cubed, which direction does it move, Luis?
Because left.
Really? Did you type it in and look at it?
Well, I wrote mine as y equals parentheses x plus 4.
And which direction did it move?
So left
So which direction do you think minus 4 is going to move?
to the right.
We need a plus 4 there to move to the left. Cool. Daniel actually jumped ahead. He went down to here. So I'm going to write down what Daniel wrote. How about right by 2? Somebody want to volunteer? What would my equation be if I wanted to go right by 2? What goes in there? Tucker?
Y equals X minus 2. Cubed.
Guys, remember this from quadratics, which is this was the weird one where it's the opposite of what you think it's going to be because you want to think about what makes it equal to 0. If I put in a negative 4, I get 0. That means I'm going negative to the left. I put in a positive 2, I get 0. That means I went to the right. I put in the opposite of what I see here. And we've got y equals x minus h cubed. And if h is positive, it goes to the right. And if h is negative, it goes to the left. But remember, it's h that is positive and negative, not the equation that's positive or negative. The equation is x minus some number. If I make the number positive, I'm going to write x minus a number. If I make the number negative, I'm going to write x minus a negative number, which always gets shortcut as x minus a negative. How do I write minus a negative?
Positive.
Plus. Okay. All right. One more. I want to make it go up faster. And I want to make it go up slower. So I want my graph to be steeper. And I want my graph to be less steep. What do I do to my equation to make it go up faster or to go up slower? Here's my normal graph right here. There's my normal graph. Looks like this. Here's my normal graph. Looks like this. What can I do to my equation to make it go up faster? And what could I do to my equation to make it go up slower? Quickly, because we're running out of time. Louise, can you give me an example of something that makes it go up faster?
You have to put a number on the parentheses.
What number? Give me an example.
Anything like at a really high number.
Like that? Yeah. This is going to go up if I think about my quick graph. Instead of going up 1, that'll go up 4. That goes up faster. Amber, how about slower? What number could I put in front that would make this not go up as quickly? Instead of going up 1, I want to go up something less than 1, right? What do I multiply it by to make the 1 be smaller? What could I multiply by that would make that 1 get smaller? Well, if I multiply by 2, don't I go make that equal to a 2? But I want to make it smaller instead of bigger. What number could you multiply that would make something get smaller? Half. So I want to have a stretch factor of a. Guys, looking back, just like on the parabola, I just put an a value in there. Y equals ax cubed. And if a is bigger than 1, it's going to be stretched. And if a is between 0 and 1, it's going to be compressed. Probably write the word stretch and compressed there. So let's put this all together in the last 30 seconds. Y equals a parentheses x minus h cubed plus k. This is our general equation. Write it down, highlight it. Does that look awfully familiar? Doesn't that look just like the quadratic one that we did? Hey, look, there's the graphing form of a cubic, just like the graphing form of a quadratic. Cool. Hey, guys, little quick advanced planning. Tomorrow, we're going to look at a couple more of these. And then during T3, we're going to do a quick review of what we've done in Chapter 2. Because over the weekend, I'm going to give you a quiz to do at home on formative. A quick quiz on what we've done so far in Chapter 2. Have a great day. We'll see you tomorrow morning.
Good job.